friends, I am Dr. Bagade, and today I am going to discuss about the very important chapters in CBSE pattern of 11th standard. The chapter is related with the thermodynamics. It is chapter 8, and we are going to see the details, what are the contents and how do we deal about this important topic. Now, even though we are dealing with this subject in our day-to-day life, we must need to understand the details and the technicalities and the importance of this topic, because the applications of this thermodynamics, these are not only for the day-to-day life, these are also in industry, from every segment of industrial sector. In some or other way, we are using the applications of thermodynamics. So, today we are going to talk about these topics. First, we shall deal or we shall discuss about what is mean by thermal equilibrium. Then we shall go for the definition of temperature. Then the Zeroth Law of thermodynamics, which is the foundation for defining the temperature. Then what do we mean by heat, work and internal energy. And then we shall also discuss about the first law of thermodynamics. Now, this word thermodynamics, that can be decomposed into two different words, that is thermi and dynamics. Thermi word has come from the Greek, and in Greece the word thermi means heat, and dynamics, that of course all of us we know that dynamics is something related to the motion, that means power. So, thermodynamics is a subject which deals about the power from heat, or we can also define this subject that the conversion of heat into work or work into heat, that is the mutual interaction of these two energies. To understand this subject in detail, the concepts must be known very clearly. Therefore, we first start with the concept of thermal equilibrium. This is a very easy concept, very easy to understand, but very important from practical point of view. Now, let us say, as we can see, if we take example of a cup filled with hot tea or coffee. Now, we understand that if the atmospheric temperature is 30 degrees Celsius and the cup or the tea at 70 degree or 60 degrees Celsius, there is a difference between these two temperatures of these two things. Now, what happens, what do we see? After a certain time, the tea gets colder. Why does this happens? This is very simple. This is very simple in the sense that nature likes balance. So, when tea was hot, it had higher thermal energy, and that higher thermal energy as compared to the atmospheric temperature, that created a gradient, and nature wants a balance. That means the energy from higher potential that should go to the lower potential, and that's what happens. That's what we see. What is that? The tea with lapse of time slowly gets cooler. How long does it go? It's again very simple. We all know that as long as the temperature of atmosphere and the tea does not get equal, for that time the tea will keep on delivering or dissipating the temperature, that is heat. So, this is nothing but the thermal equilibrium. I will pose another problem. Let us say we have a hot body and cold body. Let us say that hot body is at 100 degrees Celsius and cold body is at 0 degrees Celsius, and these two bodies, these two objects, these are brought in contact with each other. Now, as we know that one body being hot at 100 degrees Celsius, it had higher energy, that is the thermal content, heat energy content. So, it will give away its heat to the cooler body, that is cold body. So, 100 degrees Celsius body will slowly keep on cooling. At the same time, the body which is at 0 degrees Celsius, that will go on heating up, and this process will continue till the temperature of both the bodies does not become same. In this case, that would be 50 degrees Celsius. So, when this thing happens, that the two bodies are in contact with each other and both have the same temperature, then we say that these two bodies are in thermal equilibrium with each other. So, it is very simple concept, but very important. Now, what is Zeroth Law of thermodynamics? Based on this equality of temperature, this Zeroth Law of thermodynamics has basically been used or been adopted as the foundation of this temperature measurement. Now, let us say, as we can see in this figure, we have three bodies A, B and C. Now what does this law states? If body A is in thermal equilibrium with body B, at the same time body A is also in thermal equilibrium with body C independently. So if such condition occurs, then we can conclude that body B and C, these are also in thermal equilibrium with each other. That means the temperature of body A and temperature of body B and temperature of body C, these are all same. Now let us replace this body A with a thermometer. Now we find the practical application here. We normally use this thermometer for temperature measurements everywhere, when we go to doctor, when we perform experiments in lab. Most of the times we must have used this mercury field thermometer. So this is nothing but the basis for temperature measurement. If I measure the temperature of object A in the figure at the right of you, and that comes out to some 50 or 60 degrees Celsius, and I also measure the temperature of object B, that is also 50 or 60 degrees Celsius, then I can say that the temperature of these two bodies are same, and hence they are in thermal equilibrium with each other. The Zeroth Law of thermodynamics states that if two thermodynamic systems are in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. That is the equality of temperature. Now let us go for the practical application of this Zeroth law, that is the temperature measurement. Now how do the steel at every process or every segment we are using in constructions, we are using it for railroads, we are also using it for utensil making, we are using it for some machines. Everywhere we use different quality of metals, different quality of steel in fact, and these properties are developed in the raw material using various heat treatment processes. And one of the simple process which you must have seen, that we make the metal red hot by heating it up, and then we quench it either in water or in oil. So here what is the process related with the temperature? The heat from the metal that is transferred to the water or oil, and the metal gets cooled down. So when this metal is cooled down, depending on the method how the metal is cooled down, several different properties are established, or these are developed in that particular material. Like hardening is one of the process, normalizing is one of the process. So similarly, number of processes that goes on depending on the requirements of the specific properties. Now let us go, how do we define temperature? Now in simple words, this temperature is a thermal state of body which distinguishes hot body from a cold body. So which body is hotter, which body is colder, that has to be compared with some common platform, and that common platform is nothing but the measurement of temperature. Now this temperature of body is proportional to the molecular energy, that is the average molecular kinetic energy of molecules in this system. Now a particular molecule does not have a temperature, it has energy. The gas as a system has temperature. Now we understand that if I talk of any specific system which is filled up with a gas, assume a container which is filled with gas, might be oxygen, might be air, and if we want to measure its temperature, how do we measure it? We simply put down the thermometer into that container, and the thermometer gives us the reading, and we say that the temperature of this particular gas or the system is some specific degree Celsius, let's say 100 degrees Celsius, 200 degrees Celsius, etc. But is it really the temperature? No, it is the energy. Now the instruments like thermometers, which are used to measure the heat energy and calibrate it into some specific units, that is nothing but a thermometer. Now the instruments for measuring ordinary temperatures, these are called as thermometers, and those which are used for measuring higher temperatures, these are known as pyrometers. Here we can see several types of thermometers using different thermometric property. For example, if I use the concept of constant volume gas, then thermometric property would be the pressure P. If I use constant volume, then the thermometric property would be volume V. Similarly, in electric resistance we have resistance as the thermometric property, in thermocouple we will have electromotive force as, and so on. Now there are some interesting facts about the temperature. Now what are these interesting facts? Now through experiments several contributions have been made by many researchers and scientists. A few of them, they are Avogadro, then for temperature, specifically for the temperature measurements we have Celsius, we have Fahrenheit, we have Kelvin, and for the behavior of gases we have three major contributors, that is Boyles, Charles and Gay-Lussac. Now what were their observations? Now the first observation is very interesting. It has been found that the gas will not occupy any volume at a certain temperature. So there will come a certain state or condition when the gas will not occupy any volume, and that specific temperature where the volume is equal to 0, that temperature it is known as absolute zero temperature. Now this absolute zero temperature, it is stated in degree Celsius, although we have a conversion from degree centigrade to Fahrenheit, from degree centigrade to Kelvin, or Fahrenheit to Kelvin, etc. But the temperature at which the volume is 0, that temperature it is called as absolute zero temperature, and the point of absolute temperature is found to occur at 273.15 degrees Celsius below the freezing point of water. Now in that case we can also say that the absolute temperature would be equal to thermometer reading in degrees Celsius plus 273.15. The absolute temperature in degree centigrade is also known as degree Kelvin, and it is denoted by letter K. It is in SI units. Now let us talk about heat, work and internal energy. Now we have a very common application. This is the IC engine simulation. IC engine means internal combustion simulation. Now what do we see in this simulation? Let us look at the arrangement first and then discuss about the working. Now what happens, we have a piston which is reciprocating in a cylinder. The space is confined. We have two valves on the top of it. The cylinder is completely insulated and the piston is rotated. Now here what we can see, when the piston goes from top to bottom, there is inflow of fuel. It is not the complete inflow of fuel, it is the mixture of air and fuel, and that's why it is also called as air fuel mixture. And then this air fuel mixture, it is burnt with the help of a spark plug. Now what happens when we burn this air fuel mixture? The kinetic energy of this the chemical energy of this mixture, that is converted into heat energy, and that heat energy that evolves into rise in pressure of the system. Now what the system contains? The system contains the gases. The majority of the system mass is of the air. So the temperature and pressure of air, that will increase, and that increased or rise in pressure, that will be applied, that will be forcing the piston downwards. So this is the mechanism how it works. But have you seen the working? Have you seen the effects, or have you seen the conversion of heat into mechanical work? Yes, definitely. We have converted chemical energy of fuel by burning it. Burning is nothing but the exothermic reaction. So through this exothermic reaction we have converted heat energy into mechanical work, and that's how we develop the reciprocating motion, and finally that reciprocating motion is then converted into circular motion, that is rotary motion of our wheels. Now how do we discuss this in technical terms? Now both this heat and work, these are the forms of energy. Now can we say I have seen heat, or can we say that I have seen work? Any steady or standing object cannot give us these two quantities, but both these quantities that can be observed, that can be seen only when they are in transit, they are in motion. When I say that I move from one place to other place, then I say that I have exerted some work, I have done some work, right? Similarly, heat will also be seen only when it transfers from one object which is hotter to object which is cooler. So these both energies, these are dependent on path, and hence these are also called as path functions. Now heat is denoted by letter capital Q, and this can be defined in an analogous way to work. How? Heat is something which appears at the boundary when a system changes its states due to difference in temperature between the system and surrounding. Now I hope you have gotten the importance of temperature, isn't it? How? Unless and until there is difference in temperature, there will not be transfer of heat, and unless and until there will be transfer of heat, we cannot develop work. So like work, it is also a transient quantity which only appears at the boundary. Now like we solve various numericals, various problems, and we'll have to assign some sign conventions. Now when this heat is received by the system, then the heat is considered to be positive. That is the sign convention. And when the heat is rejected by the system, that is called as the negative heat transfer. So it is very easy to remember that when the heat is rejected, that is, we can think of it as a heat loss or heat transfer to the sink, and that can be called as the negative Q. Now what is internal energy? Let us look at this animation again. It is a schematic of some steam engine. As we can see, we have a water tank, and from this water tank water is fed into a boiler. In this boiler, from the bottom side we are applying heat. Now when the heat is applied, water gets converted into steam. That steam slowly, the temperature of the steam increases, the pressure of the steam increases, and then that the pressure, increased pressure of the steam, that applies on the piston, which is reciprocating, and thereby the motion of the piston is accomplished. We get the reciprocating motion of piston. That motion of piston, that is again converted into some useful application like pumping of water, might be crushing, might be motion, any purpose. Now we had the same thing. One fluid was there, that was water. Water, earlier it was in liquid phase. With the application of heat, that liquid phase was converted into vapor phase. How did it happen? It happened only because we had supplied heat into the system. Now the boiler where we are converting this water into steam, that comprises as a thermodynamic system. Now when water was fed into the boiler shell, it had some energy, because as we have discussed, the internal energy, every object, it is composed of molecules. Molecules has proton, neutron and electrons, and we also know that these electrons, protons, these are always in motion. So every object, whether live or dead, whatever we see, there are some molecules which are continuously in motion. The motion can be anything. The motion can be translatory motion, the motion can be vibratory motion, it can be rotary motion, it can be spinning motion, and therefore the molecules, they will have collisions with each other. So there is momentum transfer also, and this process is going always. Now what happens when we supply heat there? When we supply heat, these molecules, they gain that heat. So their energy content of this molecule, that is increased. So this energy which is contained within the molecules, but which we cannot see from outside, like the object we cannot see as it is moving, but the molecules inside it, they are now vibrating, they are now colliding with larger speed, larger momentum transfer is done. So this is happening because their internal energy has increased. So if a certain amount of heat is supplied to gas, the result is that the temperature of gas may increase, or the volume of gas may increase, thereby doing some external work. So Joule conducted number of experiments on that. Joule has a very good contribution in understanding this, the concept of internal energy, and he suggested that the internal energy of a perfect gas is a function of temperature only. So in other words, the internal energy of gas is dependent on temperature, temperature changes, and it is not affected by pressure or volume. So, we understand that the internal energy will be increased or decreased only when the temperature is increased or decreased. So, I hope with this we have understood the concept of temperature. We have also understood the concept of internal energy. In our next lecture, we shall see the first law of thermodynamics. How do we understand it and how do we apply it for the various thermodynamic systems. For any queries, you are free to contact me. Thank you very much.